Okay, everyone. So let's start the class. Okay. So just let me take some questions. So let me check. So I've given some homework question to you, all of you. Have you done those questions as well?
Yes.
Shake. Okay, please do this question and then we'll start the image formation of lenses. Okay, everyone, please do this question and let me know the answer of this question. Giving you 2 minutes. And after that, we'll start the refraction through lenses. It means that we'll do the image formations of the lenses. Yes, Maha. Yes, I will take it. No, don't worry about it. Okay, Nabila. Okay, Galvin. Okay, Aisha. Okay, everyone. So there will be like this class will be of 1.5 hours. Okay. So please be there in the class. This will okay. Okay, let's do this question. So question is saying the refractive index of glass with respect to air is 3/2. So is this absolute?
No, sir.
Is this absolute?
No.
Sure.
Yeah. Yes.
Okay. So question is saying refractive index of glass with respect to air. So everyone, with respect to air, we are taking reference medium as air. So obviously this will be absolute. I've told you about the same, that whenever a medium is involved, whenever so you have in the refraction part, two medium involves, and if one of them is air, so that will be considered as refractive index or absolute refractive index. Clear?
So is
Okay.
it's supposed to be in the numerator side?
No. Yes, it's supposed to be numerator, na? With respect to air. I've told you glass with respect to air. So it will be velocity is C by V. Got
Okay,
it?
sir. Yes, sir.
And if we talk about the refractive index of water, air, so it will be C by V water, and this will be V glass. Clear, everyone?
Yes, sir.
Any doubt so far to anybody? Please let me know once. Okay. So it means that this is an absolute refractive index. Okay. And the refractive index of water with respect to air is 4/3. So two refractive index are given to you. First one is 3/2. Okay. Second one is your 4/3. Okay. So question is saying we have to calculate the refractive index of just a moment, glass with respect to water. So what should so how you can say should I take which one should I take in numerator and which one should I take in denominator? Please tell me, Bacho.
Can you take the one with glass in numerator? Right.
Dekho, question is saying कि I need the
Water.
refractive index of glass with respect to water. So refractive index of glass with respect to water, I've told you about somewhere in the start of this chapter in terms of refractive index as well. Where is it? Sneha has I have written somewhere in the last class. चलो कोई बात नहीं, ठीक है. So as you can see, this is the refractive index given of glass will be equals to 3/2. I need the refractive index of water. That will be the index of glass with respect to water. So it will be refractive index of water. Sorry, refractive index of glass with respect to water. Okay. So it will be refractive index of glass is what? 3/2 divided by 4/3.
So the medium after respect to will be the numerator.
Madiha, oh sorry, Nabila, this is in the refractive index. This was the numerator. When we take numerator as a reference medium, we use speed. Here it is. Refractive index. In the last class, I have written somewhere about the refractive index, relative refractive index in terms of absolute refractive index. Not able to see it where I have written. Maybe I've written that thing in
question 21.
In question 21.
Yes, sir.
Achha, just a moment. Question 21. Which one is question 21, Nabila? Sample problem 21. Achha, ठीक है. 12, 21. So that is no. This is the opposite. This is the inverse.
Oh, okay. I just marked that.
ठीक है. So you can see this thing 3/2 into 4 into 3. So this is coming out to be 8/9, 9/8. So 9/8 is coming out to be 1.12. 1.125. The answer. Clear? Is this clear to all of you? Please let me know, bacho.
So I still
Yes.
don't understand what should be numerator and denominator.
Acha, theek hai, I'm telling you once again, no worries. Dekho, when we talk about the refractive index in terms of speed, okay? When we talk about the refractive index in terms of speed, what do we do is that, dear, we use the refractive index speed as the numerator, and refractive is the speed, like you can say, the medium for which I have to calculate the refractive index will be in the denominator. That will be for the speed case. Am I clear to all of you? Nabila, Maha, Galvin, Gianna, Sumaya, Aisha, Harshit. Okay?
Yes, sir.
Yeah. And if you are talking about the refractive index, we are calculating the relative refractive index in terms of refractive index. So as you can see, I have got two refractive indices. Okay, I have to calculate the refractive index of glass with respect to water. Okay. So with respect to water, so refractive index of glass with respect to water. I will do this thing with respect to water, and your refractive index of water will be in the numerator. Clear? Please,
Yes, sir.
everyone, is this
Yes.
clear?
Yes.
Yes, sir.
Okay. Okay. So that's how we will calculate it. We will take the numerator as the reference medium when we will be dealing with the speed. Okay. But right now we are not dealing with the speed, we are dealing with the refractive index. So refractive index, if you are saying with respect to, so with respect to means that with respect to medium, if I'm saying with respect to water, so with respect to water means water should be in denominator if we have the refractive index. Okay. Clear, everyone?
Yes.
Yes, sir.
Check. Okay, so this is all about the refraction part, Bacho. So let's start the image formation of spherical lenses. Achha, before starting this topic, I just wanted to ask that how Aisha, Galvin, Maha, and Sumaya. So I think 4 students are there. Aisha, Galvin, and Maha, and Sumaya. Yes, 4 students are there. So Bacho, Aisha, Galvin, Maha, Sumaya. So on Saturday, which is day after tomorrow, so at 4 p.m. KSA, I'm going to conduct the class of image formation of reflection, image formation by concave mirror, or you can say spherical mirrors. So is this completely clear to all of you, Bacho? Do you have any clash with this timing?
No, sir.
No, sir.
Aisha, Galvin,
sir.
Maha, Sumaya. Sure. Is there anybody who wants to take the backup? You can say who wants to revise this topic from the previous students, the old students? Galvin, Nabila, Harshit, Gianna.
Sir, can I join?
Is this Nabila or Gianna?
No, sir, this is Gianna.
Gianna. Okay, Gianna. Okay, no worries. You can also join, dear.
Sir, I
You can
might
also join.
join. Is it possible, like, you can send the link, but I'll check later?
Nabila, you're saying something, dear?
So if they send the link and I don't join, is it okay?
That is okay. I will ask them to share the link with you if you want to join. Do you want to join?
Yeah, okay. Maybe I'll look at the time because I have
Acha,
guests.
ठीक है. ठीक है. देखो 4 p.m. case से, and if you talk about the UAE timing, that would be 5:30. Not 5:30, that would be 5 o'clock. 1 hour difference. There is a 1 hour difference, na bacho?
Yes, sir.
Maha, you are saying there 6 to 7 KSA. Okay, just a moment.
Sir.
Yes, Maha, Gianna.
Sir, on Saturday.
On Saturday, yes.
So I have another chemistry on Saturday class tuition.
Achha, ठीक है.
At 5.
At 5 UAE timing of 5.
Yes, sir.
Achha, ठीक है. So when you will, so after, it means that at 6 o'clock, according to UAE time, you will get free.
At 6, yeah, yes, sir.
At 6. So after that, do you have any class, Maha? Sorry, Gianna.
No, sir.
ठीक है. So Maha, you are asking 6 to 7 KSA. 6 to 7 KSA means that would be, according to Indian time, that would be 8:30. So you are asking about 8:30 class or 9:30. Yes or no, Maha? Is this the time you are asking for? Maha?
So this is Jana.
Yes, Gianna. Basically, Maha is also asking for another timing.
Yes, sir.
ठीक है. I got your point, Gianna, that you will get free by 6 o'clock at according to UAE time. That would be 7:30 of Indian time. Okay, ठीक है. Yes, Maha, you are saying something?
So can I take classes from like 6 to 7 KSA timing?
KSA timing. So it would be 8:30 according to Indian time. So
Yes, sir.
8:30. Okay, so okay, ठीक है. Let me ask whether this time slot is free. So if all of you are free at this time, please let me know once. 8:30. Aisha, Galvin, Maha, and Sumayya. All of you are free. 8:30 means according to KSA time, that would be 6 KSA, 6 p.m. KSA. And according to Dubai or UAE time, that would be 7 p.m. UAE time. All of you are free according to this. Please let me know once.
Yes, sir, I'll be free.
Aisha, Galvin, Maha, Sumayya. Please let me know once, Bachol. Are you sure you are free?
Yes, sir.
ठीक
Yes,
है.
sir.
Let me. ठीक है. Okay. Gianna, 8 means 8 o'clock according to Dubai time. Let me show. Gianna, अच्छा. ठीक है. Sunday में on Sunday do you have any classes? I can join at 5 itself. 5 UAE time. Okay, actually, basically, two students are getting asking for the another timings like Maha and Gianna. So I have to make the timings. Actually, that class might be of 1.5 hours because that is a backup class. So I might extend the class for half hour. ठीक है. So that will be 5:30, 6 o'clock you have class. Chalo, ठीक है. I will let you will I will ask from the management about the same. Okay, because actually two timings are clashing at the same time. Maha is asking for 6 p.m. KSA and at 6 p.m. You can say Gianna have the class till 7 p.m. So according to this. So let's see what we can do. Okay, everyone. No worries. Okay. So let's start the class, this topic, okay, without any delay. I will try to complete this convex lens first in this class itself. Okay, so first of all, let's do the basics of this chapter topic. So basically, similar to the reflection part, we have refraction in the lenses. Okay, and in this part, we are going to study and analyze the images formed by the lenses. Okay, so first of all, let's do the, just a moment. Here it is. Okay, so let me draw the figure of. So we have two types of lenses, everyone. In this chapter, we have two types of lenses. First one is convex lens. Okay. Second one is concave lens. Okay, so let me draw the figure of concave lens. So concave lens is just like this. Okay, and the this is concave convex lens, and the concave lens I'm pasting in the figure because the figure is a little bit. Okay, so actually, so that's why I've taken this picture, because drawing the concave lens is a little bit tough. So as you can see, these are the two lenses that we have in our syllabus. Okay, and the first thing that is there in this topic is let's start. So this is the center of the lenses called optical center. Okay, everyone. So basically in the lenses, refraction happens. Okay, but in the mirror, reflection happens. Okay, yes or no, everyone? So
Okay,
this is
sir.
the center point of the lenses, of both the lenses. This center point is called optical center. Are called, yeah, is called. It's called आपका optical center. Okay, everyone.
Okay, sir.
So basically, in the mirror part, we have two focus. So in the mirror part, we have only one focus point. Okay, but in lenses, the light can travel in both the direction. As you can see, that light will pass through it. So it can basically. So in the lenses part, so we have two focuses. Okay, in the mirror, we have only one focus. Okay, so let me draw the figure of this lens first. Spherical, we are doing the convex lens first. So this lens is also called converging lens. Converging lens. Okay, so let me draw the figure. So this line is called what? Can anybody tell me what is the name of this line? This line?
Principal axis.
Principal axis. Principal axis. So everyone, so basically on the in the lenses part, so we have two focuses. So this focus on the right hand side, because light travels in the forward direction, in the rightwards direction. So this focus is called as primary focus, or f1. Some, like in the books, so it basically changes. Sometimes in the books it is given as f2, and sometimes it is given as f1. Okay, so no matter if you take is f1 or f2, doesn't matter, it will not change. Okay, so no need to worry about this thing. And this is called 2f2, sorry, 2f1. So 2f1 means twice the value of focal length, so that will be your center of curvature. Clear, everyone?
Yes.
Okay, sir.
Okay.
Yes, sir.
On the left hand side, that is your f2, and this is your
2F.
2f2. Clear? Any doubt so far to anybody? Please let me know once.
No doubts.
Is there any doubt so far? Please let me know once again. Okay.
Yes, sir.
So if you talk about the properties of this lens, is basically this lens forms real and inverted images in except one cases. Only one case is there in which it will not form the real image. Similar to the concave mirror, only one form was there. Only one case was there in which it was like the concave mirror was not forming the real images, right? So first thing that is convex lens forms real and images except in one case. Okay. And as you can see, this thing, light travels in the rightward directions. It will refract from this point. Okay. This point at the boundary, refraction will happen. Okay. And if the light ray is parallel, so obviously it will if the light ray is parallel to the principal axis, so it will pass through the focus. Yes or no, everyone? Similar to the previous concept that we had done in the reflection part.
Yes, sir.
Okay. So all of you can see this thing that light is traveling along the straight line, along basically parallel to the principal axis. It will refract and it will pass through the focus. Okay, everyone. Maha, Gianna, Galvin, Nabila, Sumaya. Is this clear?
Yes, sir.
Okay.
Yes, sir.
So yes, as you can see, light is going in this direction, and basically I have to so in the mirror part we calculate the distance from the pole, but in the lenses we calculate the distance from the optical center, right? So just a moment. So this is direction of light. Okay. Direction of lights. So I have to calculate the focal length here. So primary focal length, this F1 is called as primary focus. Primary focus, okay? Because light ray is going in the forward, in the rightward direction, and the ray is also getting basically refracted at the primary focus. So that's why this distance, I'm standing at the center, at the optical center, and I'm going in this direction. So it will be positive or negative?
Positive.
Positive. Positive by
Positive.
Harshit. Okay. What about rest of you? Gianna, Maha, Galvin, Nabila, and Sumaya, Aisha?
So positive.
Positive.
Yes, positive, everyone. Because I'm going in the same direction of light, because optical center is here and F1 is here. I'm going in the direction of light, so it will be positive. So the primary focus from in the 10th standard, you only have you have to deal with this primary focus only. But when you will go in the higher standards like 11th and 12th, then you have to do deal with the secondary focus as well. Okay. So I'm writing here the primary focus of lens is always clear, everyone. And as you can see, object distance, obviously it will be negative because we always place the object on the left hand side of the lens or mirror. Yes or no?
Yes, sir.
Clear? Any doubt so far to anybody? Please let me know once.
No, sir.
Any doubt to anybody? Please let me know. Are you sure, all of you? Please let me know once. Is this clear or not? At
Yes,
least
sir,
say
it's
yes or
clear.
no.
Sir, it's clear.
It's clear. Chalo, okay. Okay, so uh, always forms real images, always positive. Yeah. Okay, so this is all about the converging lens. This is all about the convex lens. Okay, always remember, always remember that this thing that whenever you hear the word convex, focal length will be positive, irrespective of the lens or mirror. If this is called convex mirror, obviously convex mirror has positive focal length, and if this is convex lens, so obviously this is positive focal length. Okay, if you hear the word concave lens or concave mirror, so that will be negative. Clear, everyone? Is this clear to all of you? Please let me know once. Any doubt so far to anybody?
Yeah.
Sure.
Sure.
Okay. So keep this thing in mind so that basically it will help you a little bit. Okay. Okay. So let's start the image formation. So the new students like Galvin, Aisha, Maha, and Sumaya, I will let you know after this class, okay, about the timings. Okay, so that you can all join at the same time. Okay.
Okay, sir.
Okay. So Gianna, do you go to church on Sunday as well, dear?
Yes, sir.
Gianna. Okay, okay. Okay. So same timing, Gianna. That is 8 o'clock.
No, sir. 8
Okay.
o'clock I'm free on Sunday.
8 o'clock you are free on Sunday. What about you, Maha, on Sunday?
Sir,
About that. Yes, you said something, Gianna.
so sorry, sir. I have tuition of math
Acha,
on 8 o'clock tonight.
8 o'clock. Acha, that will be 9:30. So I will try and share the link so that okay. Okay.
Yes,
So
sir.
let's focus here. Okay. So image formation. Sorry, let me write instead of image formation, I'm writing only convex mirror. Okay. So first case is very similar to the reflection, Bacho. That is, your object is placed at infinity. So basically, this is the repetition of the concave mirror. Okay, when you do the concave mirror, so it's the repetition in the convex lens at infinity. Okay, so at infinity. So suppose your object is placed. So just a second, let me draw the mirror first, the lens first.
Sir,
Yes, Harshit.
sir, in infinity, why there will be like two rays?
Harshit, देखो. For the formation of image, we need two rays at least. Because
Just
one
for
ray cannot
infinity.
form just for infinity. I didn't get your word, Harshit.
So like in this only case, we have just required two rays.
No, we can have multiple rays, Harshit. I'm not like I haven't said yet that you can only only two rays are present. So rays can be infinite, but we take only two rays because two rays are enough for the image formation.
Okay.
Okay. Yeah.
Okay.
So that is your optical center. So first of all, this is your F1. This is your F2, F2, F1, and this is your F2. This is your 2F. Clear? So your rays are coming from infinity. Your object is placed at infinity. So rays will be parallel to the principal axis. All of you, is this clear?
Yes, sir.
Chicken. Yeah. And it will refract. as you can see. So is this clear to all of you that light is getting refracted at the focus? So that's why this lens is called the converging lens. Okay.
Okay, sir.
Okay. So as you can see this thing, this lens has the ability to converge. It means that to direct the rays at focus. Okay. So your object is at infinity.
So, sir, there's no behind the, like, in the mirror, there was like behind the mirror or something, right?
Your
With
voice is
dotted
lagging a
line.
little bit, Nabila. Please speak it louder.
So, do we have dotted lines?
No, in this, we don't have dotted lines. Dotted lines are only used when we draw the, you can say when we extend the line in the backward direction. As you can see,
So,
light
is
is
there,
basically passing through the lens. It is basically passing through the lens.
okay, sir.
Okay.
Is there a
Yeah, it is.
behind the lens? Yeah.
No. There's no behind the lens.
Okay, sir.
In light can travel in both the direction in lenses. In mirror,
Okay.
only one because refraction means bending of light means one medium to another medium. So obviously, the traveling path will be same, but there will be a refraction. Okay.
Okay, sir. Thank you.
Yeah. So U is at infinity, all of you. Object is at infinity. V is at focus. If I'm writing F only, so always consider that that is the primary focus. Okay. Primary focus for the convex lens is on the right hand side. Clear, everyone?
Yes, sir.
And nature will be real and inverted. Okay. Size that will be highly diminished. Point size. Is this clear to all of you? Please let me know once. Any doubt so far to anybody?
No, sir.
No, sir.
Okay. So this is the first case. Sumaya, Maha, Galvin, and Aisha. Is this clear, Bacho? Because for you, this is a completely new topic because you have not done the reflection part. So please let me know if this is clear to you.
Yes, sir.
Sure.
Yes, sir.
No worries. I will take your reflection part as well. Okay. Don't be panic. I will take your part before your exams. No need to worry about it. Either on Sunday or Saturday, I will try to manage somehow. No worries. Okay. So this is the first case. So let's talk about the second case. So as you know this thing, when the object is in infinity, it basically move towards the optical center. So when the object is in infinity, now the object will come beyond 2f2. Similar to the case of curvature, beyond curvature. Yes or no, everyone? Remember?
Yes, sir.
Yeah. And this is the first case. So second case is beyond 2f2. Okay. So I'm erasing this thing. So your object is somewhere here. Okay. So first ray should always be parallel to the principal axis. It will pass through the focus. Remember this thing, Bacho? First ray should always be parallel to the principal axis. When we draw the image formation of an object, we always basically make the first ray parallel to the principal axis. All of you, is this clear?
Yes, sir.
Yes, sir.
Any doubt to anybody? Okay. We always take the first ray parallel to the principal axis and it will pass through the focus irrespective of the type of lens mirror. Okay. Second thing that I will take is that, so when the object passes through the optical center, basically it will go without refraction. Okay. Because it basically strikes the optical center at the 90-degree. Clear, everyone? So that's why at the 90-degree, no refraction will happen. Clear? Please let me know, bacho.
Yes, that's clear.
This is a kind of similar to the center of curvature. No, sorry, center of curvature, ni pole. Okay. Clear?
Yes, sir.
Okay. As you can see, this thing, that image is forming here between F1 and 2F1. So it will be like this, inverted image. As you can see, the image is formed by the intersection of the refracted ray. Okay. The point at which the refracted ray intersects, it basically forms image there. Okay. So the first, so object is beyond 2F2, 2F1, 2F2. अच्छा थोड़ा सा ऊपर लिख देता हूँ इसको. ठीक है. And your image is basically between F1 and 2F1. ठीक है. Nature is basically real and inverted. ठीक है. And size would be diminish. As you can see, the image is smaller than the object. Yes or no, everyone?
Yes, sir.
No, sir, it will be same size.
No, Harshit, it will not be of same size. When it will form the same size image. Clear?
Sir, could you repeat, sir?
हाँ हर्षित, yes, बोलो बच्चे, क्या हुआ?
Sir, could you please repeat what you said?
I'm saying when the object is beyond 2F2, it will form. Harshit, please mute yourself. Actually, there's some background noise. Okay. When the object is placed at beyond the 2F2, the image will form between F1 and 2F1. Okay. When
Yes,
the
sir.
object is placed at 2F2, then it will form the image at 2F1, exactly at the 2F1. Harshit, please mute yourself. There actually some mic issue is there at your end. Okay.
Yes.
Is this clear to all of you? Please let me know once.
Yes, sir.
Now the object will move towards the optical center. So the next part would be 2F2 at 2F2. Okay. Now your object is at the 2F2. So you have to take the first ray parallel to the principal axis and it will pass through the principal focus. Yes or no, everyone?
Yes, sir.
And second ray, I will pass through the optical center. Okay, I need 2 rays. So I will pass through the optical center. As I can see that it will go without any refraction like this. Okay. So there is some asymmetry due to rough hand drawing. Actually, I am not drawing with any kind of scale. It's a complete rough hand drawing. So please pardon me for that, Bichu. Okay. As you can see, the intersection point is basically absolutely lying beneath the 2F2. So that is the 2F2. Okay. So the image, as you can see, the image is of exactly same height of the object. Okay. So your U at 2F2, V is equals to basically U is at 2F2. Actually, my laptop is hanging a little bit. So U is at 2F2 and your image is formed is at 2F1 and your nature of image would be real and inverted. Size would be same size. Please let me know, everyone. Is this clear to all of you or not?
Yes, sir.
Any doubt so far to anybody? Please let me know once if you have. Why is everybody silent? There are 8 students in the class and nobody is responding. What happened? Is this not
No,
clear to you,
that's
Bachu? This is a very important topic. So please, if it's not clear, let me know. Okay.
okay, sir.
So the next thing that is there. So as your object was at 2F2, now the object will lie between 2F1, 2F2 and F2. Okay. Fourth is between okay. So now your object will be somewhere here. Okay. Will pass through the focus. Sorry, take a first principal axis and it will pass through the focus. Okay. And the second ray, as usual, it will pass through the optical center without any refraction. Okay. So as you can see, this is basically intersecting beyond 2F1. So your image formed will be beyond 2F2 and you can see the image forming is basically larger than the actual size of the object. Yes or no, everyone?
Yes, sir.
So,
Okay. Yeah. So U basically was between F2 to F2 and F2. V is equals to, it is beyond 2F1 and nature will be and inward. And size will be, can anybody tell me the size?
Highly enlarged.
Not highly enlarged, that will be enlarged only, Harshit. Okay. So
Okay.
this is only enlarged or magnified, you can say. Is this clear to all of you? Please let me know once.
Yes, sir.
Yes, sir.
Sure.
Yes.
Chalo, check.
yes.
Next thing. Next is the second last case when your object is at focus. ठीक है F12. So now your object is placed at the focus. First ray should be parallel to the principal axis. It will pass through the focus. Yes or no, everyone?
Yes, sir.
Yes, sir.
Second ray will pass through the principal optical center, and there will not be any refraction. Okay, so you can see. As you can see, the lines are parallel to each other. The refracted light rays are parallel to each other. So as you can see, they are going to meet at infinity. What we say about the parallel lines? That parallel lines basically meets at infinity. Yes or no?
Yes, sir.
So
Yes.
U was at F2 and V is at infinity. Nature would be inverted. Size would be highly enlarged or highly magnified. Okay.
Okay, sir.
Is this clear to all of you? Please let me know once, Bichu.
Yes, sir.
Okay.
Yes, sir.
So, okay, now let's move. Just a moment. Aisha, Galvin, Gianna, Harshad, Maha, Nabila. Sumaya is not there. Is this clear to all of you? Please let me know once again.
Yes, sir.
Yes, sir.
So there are more than 6 students are present, but only 2 or 3 are responding. Why? Like right now, when I called the name, then all of you responded, but else like only Nabila or Harshit was responding. What about rest of you, Maha, Gianna, Calvin? Are you not there in the class with you? Or are you getting my point? Is this clear? Please
Yes, sir.
let me know,
Yes,
because
sir.
this is a very important topic. This is a very important topic. Okay. This is a very important topic. Okay. So now your object is, this is the last case, similar to the concave mirror case. Okay. So now this is the last case. It means that your object is placed between F2 and O. Okay. So sixth case. Okay. And okay. The first ray will be parallel to the principal axis and it will pass through the focus. Okay. So second ray, it will pass through the optical center, but as you can see this thing, the 2 light rays are basically spreading out as we move forward, as we move in the forward direction. Yes or no? They both are going in the different directions. So are they gonna meet in this forward direction if I extend these lines?
No, sir.
No, sir.
No, no. So in that case, we will do what? We will extend the line in the backward direction. We will assume that light ray is basically going to, just a moment, meet at some
Behind the
point in behind, not basically here. Okay.
Okay, so all of you can see this thing. When I extend the line in the backward direction, I can easily see this thing that these two lines are basically meeting somewhere when we extend in the backward direction. Okay, so this is the image formed by the lens in this case. So this is the case we use in the magnifying glass. Have you seen, how many of you have used the magnifying glass? Have you seen
Yes, sir.
magnifying glass? Yes, okay. So this is the case that we use in the magnifying glass. We basically place the lens magnifying glass between optical center and focus. That's why we see the large image of the object. Okay. And this is the, as you can see, this is the upright image. So this is called virtual image. Yes or no, everyone?
Yes, sir.
Yes.
So U will be equals to between and O. V should be equals to behind the lens. On the same side of the lens, you can say. Nature would be virtual and direct, as you can see this thing. Okay, and size would be enlarged.
So, sir, this extended line is a dotted.
This external line is dotted. When we extend the line, this yes, it is dotted. Clear, all of you? Please let me know once.
Sir,
Any doubt so far to anybody? Harshit.
sir, why the size will be enlarged? It will like diminished behind me.
नहीं. Harshit, object. This is the object. This is the image. देखो ना, object छोटा, image बड़ी है.
अच्छा, oh, I understood. Okay, sir.
ठीक है?
Okay, sir.
Sure. For
Just
me,
a
the
moment.
extended line is going.
Just yes, Nabila, you said something.
Nothing, sir.
अच्छा, ठीक है. Please let me know once you are done with this.
Answer.
Sure. Great. Sure, that's great. Okay.
Yes, sir.
Okay. Okay, so this is the image formed by the convex lenses. Clear? So these are the 6 cases that is very similar to the concave mirror. Okay, so as we move forward, we are only left with the concave lens. So in concave lens, only have 2 cases. Okay, only 2 cases similar to the convex mirror in the reflection part. So let's move forward to the convex mirror, concave mirror, and complete this topic. Okay, so just a moment. Okay, before that, let me tell you the you can say the use of convex lenses, applications of convex lenses. Because sometimes 2 mark question comes into the exam that they say what is the use of the convex lens. So you should have the idea before starting. Okay. So let me paste one summary of this topic, like of this image. So basically in this table, the order is opposite. Basically, they have taken the, you can say, they have taken the last case as the first. Okay, according like if we have taken the virtual case in the last, but in this table it's taken as a first case. So don't worry. Okay, so don't get confused with it. Right? Is this clear, bacho?
Yes, sir.
Yes, sir.
Convex lens. So basically, we should know the actual use of convex lens. Okay, This is the first case. First use of the convex lens is to correct the defective eyes. So basically, as you can see that our human eyes also gets weak. So that's why we develop some defect in our eyes. So we use convex lens to treat or correct the defect of vision, that is called hypermetropia. Okay? You will understand this thing like this hypermetropia in human eye defect. Okay, don't worry. Are used in spectacles. Correct. The defect of vision. Or this clear to all of you?
Yes, sir.
Again.
Yes, sir.
Sir, can you read it?
Okay. Convex lens are used in spectacles to correct the defect of vision called hypermetropia. Okay. Is my writing not readable, Bachu?
No, sir, it's understandable. It's nice.
Check. Actually, it's a little bit slippery right now. My writing pad is a little bit slippery due to the humid weather in Delhi. Okay. So next is basically convex lens. Is used magnifying glass. Okay. Second use is basically used for making a simple camera. Okay. Clear, everyone?
Yes, sir.
Yes, sir.
Okay.
Mm,
So, any doubt to anybody? Please let me know once.
No, sir.
Okay. Okay. So next topic, let's understand the next topic, that is the concave lens. So concave lens is a short topic. Okay. Just a moment. Concave lens is a short topic. So let's understand the properties of convex lens first, and then we will draw the ray diagrams. So all of you, as you can see this thing, that similar to the convex lens, concave lens also have two focuses. This and it is f2, and that is 2f2. That is f1, and this is 2f1, and this is called optical center. So you can see this thing that basically in the concave lens, the concave lens is called diverging lens. Diverging means it spread out the light out. Okay, it spread out the light. Suppose if the light ray is going like this, so it will not converge. Instead of that, it will basically diverges the light in the another direction. Okay, so that's why the concave lens does not form any real images. As you can see, they are both basically diverging as they are moving forward. So what we do is that we basically form the extended light rays and form the virtual and erect images. Clear, everyone? So just a moment. So like, as you can see, the concave lens is basically diverging the rays. So the primary focus will be this, because light rays are not getting intersecting at this point. Okay. So we have to draw the light rays in the backward direction. So this will be the principal focus for the concave lens. Am I clear to all of you, bacho? Please let me know.
Yes, sir.
Yes,
Okay.
sir.
Check. The first property of concave lens is concave lens always form virtual and erect images. Okay. Second is concave lens negative focal length. Is this clear to all of you? Please let me know once. Any doubts so far to
Yes.
anybody?
Clear.
No, sir.
Chalo, ठीक है. Just a moment. Concave lens has a negative focal length. Okay. So let's do the first thing about the concave lens, that is the image formation. First case basically similar at infinity. Will be at infinity. So this is f2. The rays are basically coming from infinity. So they are parallel to the principal axis. And what will happen is that it will basically diverges out due to the diverging nature of the lens. Clear, everyone?
Yes, sir.
Okay. So as you can see, they are not meeting in the forward direction, but what we can say is that if I basically draw the lines in the backward direction like this, So basically they are merging at the focus. Okay. Is this clear to you, everyone?
So is it dotted?
Yes, it is dotted here because we are drawing extended lines. Okay. Okay.
Okay,
So this is the first ray. So U is at infinity. V is at F2. Nature would be real. Sorry, not real. Virtual and erect. And size would be highly diminished. Is this clear, all of you? Please let me know once.
yes, sir.
Yes, sir.
Okay. Yeah. So second case is basically it says that wherever you place your object between infinity and optical center, okay, you will get the same result. Okay. Between optical center infinity and so wherever you place your object between infinity and optical center, doesn't matter. Okay. So it's your choice wherever you are placing, and the first ray should be parallel to the principal axis, and it will basically diverges out. Okay. Second ray will basically pass through the optical center, as you can see. Okay. So if, as you can see this thing, these two rays are going in the opposite, like in the different directions, so they are not gonna merge. So if I extend the line in the backward direction, because this line will meet at the principal or at the focus due to the, as you can see, this line is parallel to the principal axis. So it will pass through the focus, obviously. So you can see that this is the intersection point of these two rays. Okay. So this is the point of image formation. Clear, everyone? Please let me know once.
Yes, sir. Clear.
Okay. U is between infinity and O. V is equals to your position of image is CBSE. Just a second. Aisha, please give me 5 minutes, dear. It's about to end the class. Please give me 5 minutes. Okay. So V is at between O and F. O and F2. Okay. So nature would be virtual. Size would be diminish. Is this clear to all of you? Please let me know once.
Yes, sir.
Yes, sir.
Any doubt? Any doubt to anybody?
No, sir.
No, sir.
Okay. Okay, so these are the two cases in the convex or concave lens. Okay, so now let's move forward to the use of convex concave lenses. Okay, so first case that is here is the concave lens is used to correct the eye defect called myopia. Okay. The next thing is this. Okay, so concave lens is used in Galilean telescope. Okay. Here, everyone.
Sir,
Yes, Nabila.
that Galilean, what is that?
Galilean, Gali. Len, Lean. Galilean.
Okay.
Okay. Yeah. So only two cases, are enough. Two uses of you can say concave lens are enough. Okay.
So what is
So
Galilean telescope?
so dear, basically Galilean telescope is a kind of telescope that we use to see the celestial objects. Okay, so it's a type
Oh,
of
okay, sir.
telescope. Okay, that's great. Okay, so your image formation part is clear. Only the you can say the questions are left of this topic, and we will do the questions in the next topic, which will take in the next class. Okay, so image formation of going. And in the next class, we will be having an assessment of this topic itself. Okay, everyone?
Okay, sir.
That's great. Okay. So I hope this is clear to all of you. Any doubts so far to anybody once, please let me know.
No, sir.
No, sir.
Check it. Yeah. So just a second, let me check. Is there anything left out there?